Miram, BIM application specialist at ARKANCE, and over here with me we have host as a Kirtana, which is from Ethos. Then we have Prakriti who is going to conduct this particular session. But in between that, I would like to take few minutes to introduce our company, that what ARKANCE are and what we do. So just allow me a second to share my screen. Okay. So over here, we are ARKANCE India Private Limited, and we are involved in a lot. We are placed everywhere on the globe. We are in America, we are in India, we are in Australia, we are in Europe. We have almost 150 of technical resource as of in India. We have 40 plus offices all over the India, and currently we are growing as software company, hardware company, sales, and other support staff as well. So that is what we do, and we are also technical industry leads over here. We also have projects that we are working on, right? So as of now, we are all of the globe available over here. Then we focus not just AEC industry. We are focused on AEC specifically, but we are more focused for manufacturing, education. We provide training solutions for professionals, for corporates, for government. We also provide the knowledge transfer over here for different softwares, for different processes. If you want to learn BIM, we are the one who can help you in that. Then if you want to learn any other software which is related to AEC industry or media and entertainment, if you want to move ahead any with government company as well, we are always over here to help you. Then we also provide consulting services, as well as we are also in hardware sales and service, and we are also available at the local location for graphic arts and computing as well. And this is our portfolio that we are working in these industries, focus industries, and we are also covering the education and training and services and consulting and softwares and hardware. So this is our portfolio over here. Now we'll be looking forward at the focus on what design advance is, what is the theme of your design advance, what criteria we are going to follow. Let me just stop sharing my screen, and I would like to call Kirtana to elaborate more about design advance. Kirtana, over to you.
Yeah. Hi, everyone. I'll quickly share my screen to take you through the design advance brief. So are you able to see my screen?
Yes, Kirtana.
Yes.
Okay. Okay. So we'll be going through the theme, task, guideline, and participation, and few FAQs regarding the competition brief. So let's get into the theme. So theme is Beyond the Game, Adaptive Arenas for Tomorrow. So in Design Advance 2025 is mainly about future of public architecture. So it focuses on multipurpose arenas that embrace the concept of flexible and reversible architecture. So we are designing structures that are going to be that can seamlessly transform, relocate, or disappear based on the evolving needs. So back in times when you see the arenas were constructed and used for human gatherings, hosting major events and cultural celebrations, which were quite fixed single-use venues, which are now considered to be outdated. So the fixed single-use venues are quite wasteful and rarely used to their full potential. So our theme focuses on multi-purpose arenas that can adapt, transform, relocate, and be disassembled in response to the changing needs. So let's get into why there is a need for adaptive arenas. So back in times, like how I said, it was used for gathering people across cultures, and the purpose remains singular. And through the period of time, there is a change in needs. Entertainment spaces grew in demand, and the cities densified and entertainment diversified. The stadiums could no longer stay idle between events. So there existed a need for multi-use venues, so that the same place can be used for different events, different sports, and hosting a lot of events at the same time. So the stadiums require that kind of design. So let's get into the challenge. So the challenge is to design multifunctional, sustainable, accessible, and future-proof designs. And like how we are talking, it should not be single use. It should be transformable, relocated, and disassembled with respect to the needs. And also, it should be used for both large scale and small scale gathering with ease. So let's get into the guidelines for site and program. So the proposed site should preferably be set in an urban setting where culture, sports, and entertainment meet. So the site requirements is 10 to 15 acres and capable of accommodating around 40,000 spectators for major events. So the environmental factors such as climate and cultural significance should also be considered, and local bylaws should be followed. If we do not have the local bylaws for that particular area that you're choosing, then you can go for NBC. Also, the design outdoor spaces should be flexible extension of the entire venue. So there are a few design considerations that we need to take into consideration. That is adaptability and multifunctionality, scalable seating and crowd management, universal accessibility and user experience, sustainability and climate responsiveness, ephemeral, reversible, and circular design, cultural sensitivity, and architectural identity. Smart infrastructure and digital integration as well. So when we see about prices, there are certain cash prizes for the first three winners, and all the participants get a participation certificate and recognitions for the institute that adopt the brief as a studio project. These are the participation details that you can see. So the registration closes by 16th of October, submission closes by 29th of October, and all the UG and PG students and also the young professionals from the fields of architecture, planning, civil engineering, and design can participate globally. So you can team up with a maximum of 3 members per team, and interdisciplinary and inter-college competitions teams are also allowed. So there are a few frequently asked questions that we can get into. So like how we already spoke, is there any registration fee for competitions and workshop? No, this is totally free. Can postgraduate students take part in the competition? Yes, UG and PG students of architecture, design, civil engineer, and related fields can take part. Can the team members be from different colleges? Yes, inter-college teams, inter-batch teams are allowed. In the absence of local bylaws, which standards should be used? So NBC can be taken if there are no local bylaws. So can we choose a site on our own? You can choose an urban site in tier 1 and tier 2 cities of area 5 to 12 acres. Can we define our area programs? Yes, you can choose the functions and distribution of space allotted as per your site requirements. So this is the scan code. You guys can scan and then register for the competition. And any doubts, you can just put it in the chat box. That's all from my side. Thank you.
Thank you, Kirtana, for the introduction and the brief. Now I would like to call Prakriti. She'll be heading towards for the session of generative design, how we can use it in arenas and how we can build the generative design using over here for arenas. Prakriti? Yes.
Okay, good afternoon, everyone. I hope my screen is visible.
Yes, it is.
Okay, so first of all, welcome you all to today's webinar, that is Morphing Arena from Concept to Configurable Reality. So, first of all, my name is Prakriti Goyal, and I'm working in the AEC Associates as BIM project coordinator. So, I have 6 years of experience in BIM, and so I'll be discussing about how to develop arenas using generative design, like the upcoming, if I say the main trend, that is like for design, that is computational design or generative design. So we'll discuss about that. Right. So, first of all, let's have a brief introduction about our company, the AEC Associates. So, at the AEC Associates, we specialize in delivering accurate design documentations and scalable production supports to AEC firms worldwide with over 12 years of experience and 200 plus experts and 99% client retentions. And over here, like we operate as a seamless extensions of our client in-house teams. Like our partners benefit from up to 40% reduction in operational cost, improve focus. We actually provide like we bring deep expertise in BIM, CAD, and cross-disciplinary coordinations. So we have like over 200 plus member team in is led by seasoned architects and engineers bringing deep domain expertise. So that is why we actually deliver the projects on time as well as with accuracy. And Arena Projects is one of the examples that we provide in the AEC Associates. Now, let's talk about the topic. So, why we are going for the Arena Projects in like, so what is BIM? So, first of all you know. So, if I talk about BIM, so what is BIM? BIM is a software, workflow, technology. So, everything is combined. Like, BIM is actually everything. So, over there, you are providing certain information and you are getting the uh, main as built model. So, if I talk about enhancing your BIM models, you are developing everything in one software, that is Revit. So, if I talk about to enhance that design, enhance that BIM model in every stage of design, that is maybe conceptual model, schematic design, design development, as well as in the construction stage and the project which will be completed, how it will look. Okay, so as built level as well. So, how the design will proceed, so that is an approach, like you are enhancing the BIM model using certain approaches. So, first approach is your parametric design, where you provide certain parameters to Revit elements, like to building components, like you are changing materials, you are changing sizes, so that you can update your BIM model as per the design stages. Right. So one example is like if I talk about the Arena project. So we know that we have different fields, right? So we have cricket field, rugby field, like football field. So they have different sizes, right? So if we are designing those uh, fields, if we are doing designing those stadiums, we need parameters, like so that we can anytime change the sizes according to our design, right? So let's say if I want to change the field of the rugby field, field size, let's say maybe right now is 100 meters. So let's say if I want to provide maybe 12, like 120 meters, so anytime I can change it like this. So this is actually what we call this as parametric modeling, parametric design, where you are providing certain parameters and you are changing according to the design updations. Next is the computational design. So computation, so the name suggests itself, like computational design means a computer language is involved, means a human, like the user. You are the designer, architects, engineers. You are taking design related decisions with the help of computer language. So, if I say, like, okay, so I have several sizes, right? If I change my field as per like how it will look according to client. So, client can change those parameters automatically, and those will reflect in your BIM model. So computational design is actually used for like if you are going for facade design, if you are going for computations, okay, if you are going for detailed quantifications, automate, like you are automating a repetitive task. So if you have several fields, if you have several doors, several components, you are you want to change certain information in one go, right? Let's say if you have hundreds of doors, right, irrespective of families and types, okay, you have to change everything in one go. So you can do it easily by automating that task using computational design. So how it is actually useful, so I'll give you one example. So if I want to change the field size, so right now I'm doing manually everything manually over here, but if I want to automate this task, so for that, one computer language will be used, that is Dynamo. So Dynamo is actually a compute like computational design software, that is visual programming. So as you know that uh, like if you have experienced C++, so in general, if I talk about computational like maybe computer language, so we have text based programming. So all the websites, like if I go for any source, like let me just check. Yeah, okay, just give me a minute. Yeah, so any website is actually developed through certain codings. So if you like go for over here, so we have this page source. So every website, every element is actually text based. Like it contains a sentence, and that sentence will be converted into program. So that's one thing. That is one thing. But for design perspective, visual programming is used. Why? So that you can easily perceive what is happening. Like if you are going for facade design, so you can visually see how your facade is changing shapes, right? So let's say if I want to change the field size, okay, at faster rate, like if I'm sitting with my client, right, and he wants to see like what will be the permutation combinations of all the like sizes which we have for the fields, right? So for that, I'll go for Dynamo. This visual programming tool actually helps you to define, like to create organic structures, as well as to compute, right, and design, right? So let me create new. So yeah, so this is actually very much easily accessible to everyone, like who is not into programming, who knows programming, as well as like if you have seen in Grasshopper, right? So everything which is there, like everything that you have seen or not, Dynamo is easily accessible to everyone, right? So let's say if I want to change the field sizes as per client requirements, right? So you can see these are like this is in the project, Revit project, and this is called global parameter. There are various type of parameters. So it will be like if you want for that any session, so like it will be a later term, but I'm not going into that detail. So if I want to change these parameters, so I'll just need to select the parameter of the Revit. So I'll just type in the name which I need to change. And the value. So for that, let's take right. So now what I'll do, just observe over here how the sizes is actually changing. And let's say if I use this one, this parameter is actually field length. So if I want to change that, so it will give you various variations. So yeah, these rectangular nodes are actually your uh, these rectangular boxes are actually called nodes which perform certain tasks. Like you can see over here how it will look if it's 74 meters length of a field, right? So like you are actually generating various concepts using computational design. So generative design, next thing is generative design. So as you can see the approach, like we are enhancing the BIM model is actually developed in the software, the main Revit software, right? So parametric is the one step. Now computational design is another level, like where you are using automations to just like to save your time, that's it, right? So if we have a certain like limited timeline, as well as like certain information, certain, let's say, creating levels, right? Certain repetitive task which consumes lot of time, like you are creating hundred of sheets and one sheet, let's say, takes maybe 1 hour or maybe 5 to 6 hours, right? So you are automating that task so that it will save your time, as well as like so that you can deliver your project on time, right? So that is why we are going for the computational design. Next thing, generative design. So generative design is actually the part of computational design, but with AI, artificial intelligence. So I'll take a brief example. Like, so you all have seen uh, like any series in OTTs, right? So maybe Netflix, Amazon Prime. So anything, like any series, if you have watched, let's say, uh, if you have watched any horror film, right? Next day, when you visit that OTT channel again, so it will give you, the OTT channel will give you hundreds of suggestions as per your genre, as per the last watched element, right? So that is your AI. Now, if I talk about in BIM terms, so right now, whatever your project brief is, like project requirement, right? I need 5 rows of stadium. I need like the tread of row should be this. Like, if you know your requirements, generative design will generate n number of like hundreds of solutions, hundred of concepts of one project brief. So it is actually part of computational design, but AI is involved, right? Okay. So as I told you, like generative design is an iterative design exploration which uses AI to rapidly generate any design options, any concepts according to design brief. You just need to provide design brief. So why do we need this? Again, we are automating a boring tasks, right? We are providing certain like, as you know, we have like we have an option in Revit, that is design options. So if let's say if we are working with the stadium, like with a client who develops stadiums, right? So for that we need several concepts, like if the field size is this big, how much rows we need, how much like tires we need, how much floors we need, how much like where like exactly the site zoning as well, right? So we have several things to look after while designing a stadium, right? So we are just providing everything in Revit, in generative design, in like through AI we are providing everything. And what AI does, it is giving us the several options, and we can choose one and implement it in our project. So again, so generative design is helping you to check the possibilities of a design, and then you can implement in your project, right? So let's go with the workflow. Now, first, you are providing certain briefs. Like, what do you need? Basically, this is important. What do you need? You need stadium. Okay, fine. Now, for stadium, what do you need? You need row depth. You need like tires. How many tires you want? Let's say you need riser height, right? You need, if I say like according to standards, right? How many rows you will be needing, how many seats, so what will be the number of populations, right? So everything you need as an answer, like you are providing, okay, this is your site size, this is your field size, so how many people will be like how will be how many seats will be there, so everything you are actually asking from AI. So for that you are just modeling BIM model. You're just modeling a BIM model, you're providing certain parameters, you're just giving it the project brief, that's it. So first of all, you are generating the, you are creating, you are developing the 3D model, you are developing the BIM model, and then with parameters. After that, what the generative design will do, generative design will actually analyze, like will look into your brief, your design brief, and after that it will give you suggestions, different design options, different concepts of according to your design brief, and then you can implement in your project, right? So now if I talk about stadium design, so this is very much important, like uh if we are designing any stadium design na, like stadium, if any stadium, maybe theaters, maybe auditoriums, maybe like cricket stadium, like rugby stadium, and maybe football, any stadium. So these design considerations actually is very much important. So first of all, sight line, like if the person is s- like sitting at the last row, and in the second last there, if there's a person and its head distance, like you can see the eye level distance, and this person's eye level distance is actually sight line, the last row, the second last and the last row will give you the sight line. So this is very much important if you are designing any stadium. So the minimum values, So if the distance is very minimum, let's say 60, it means that a person needs to look between the heads in, like, in front. So I know, like, if you're going to cinema halls or maybe theaters, so it's very irritating, like when you have to like shift your position so that you can check what's happening in the front, right? So 60 is very minimum, and the optimal, like, and the maximum range is like 150, where even if the spectator, even if you are wearing hat, and if the front person, like has wore, like, if the front person has even helmet, that also can be visible, like. So yeah, so the sight line is very much important in designing a stadium. So this formula you will be using for that. So again, which, like, whatever we will be discussing afterwards requires maths. So yeah, general maths, normal maths. So don't worry about that, but again, it will give you great results, right? So first of all, if we talk about C, that is sightlines. D is the focus distance from the last seat, horizontal focus distance, like if the person is sitting at the last, right? And where we have the field boundary curve, right? So from here, this is the focal point. From here, the last eye of the seat of the stadium. So from this is the horizontal distance of the focus, that is focus distance. This we need to calculate for any stadium design, as well as the vertical height of point of focus. These three things are actually necessary for any design, for any stadium design. You know that what will be your seating depth, seating height, right? So that is up to you, right? So yes, again, I'll repeat this formulas. These formulas will be important for you in these kind of designs, right? And these are the minimum values as per. So these guidelines are from Star Arena, stararena.com. So those actually have designed these arenas. So they work on the arena projects only. So if I go for like a brief, Star Arena. So all the standards that you'll see over here, in, like, whatever I'm talking about is actually from this site, Star Arena. So if you want to check out the standards while designing these arenas, so you can actually check this out, check this website out. So yes, so for cricket, the point of focus, like the, like if I'm talking about this, so if field, if you have a road level, okay, natural ground level, so from there, what will be the point of focus, the distance? So like for every field this is different, right? Cricket, football, basketball, baseball, athletics, netball, handball, for every field it is different. So this is very much important once you calculate everything. So sight line is actually like you are doing calculations, right? And point of focus is necessary for those calculations. So again, as I told you, that these seating row depths, clearway, riser height, gangways, okay, the corridors, those are actually important. Now let's talk about how we go for stadium designs and how generative design is actually helpful over here. So I've prepared a generative design script for you. So let me open that. So if you're going for generative design, like if you're going for stadium designs in Revit, what is main thing over here? The calculations, right? So if I open any Dynamo, if you are going for any versions, maybe be it Revit 2021, 22, so any version. So this is actually applicable for every version. Dynamo is inbuilt plugin. You can access it through Manage tab and Visual Programming. Now, if I want to calculate the sight lines, so by default, like you can see, the different like programmers, right? So Dynamo is actually third community. Many developers, many programmers, many architects, engineers are actually involved in Dynamo community. So some people who are programmers, so they have created a script, like they have created a library for stadiums as well, that is BVN. So if you check over here, so they have, for those, like they have a library for those who want to design any stadiums, right? So let's say if I want to calculate sight line, so sight line, again, as I told you, is very much important, which will give you the number of rows. So how many like how many rows will be affected, right? How your rows offset, like how many rows in one tier, how many rows in second tier. So that will be calculated as well as C value. The sight lines will give you the row distance, row offsets, like row distance from the front row, right? So this is very much important. So I have created a script uh, for you. So let me open that. Yeah. So first of all, just see over here, I'll be opening that script. So over here, just see over here, I have provided the seating row depth. So this row depth, that is T. So if I open that like standards, so the T is your row depth. See, right? Row depth, and then N is your riser height. So we have provided these standards. Like if my row depth will be 450 or maybe beyond, like 500. So I have provided a minimum value. That is up to you what you want as per your design. So this is actually your seating row depth. And the N initial, that means according to the standard, is your riser height. So we have these two elements, as well as the focus distance. So focus distance means the boundary curve, the like from field, what will be the first focus distance, right? So if this is my field, so this is your boundary curve. So the first row will be created from the field, like that is your focus distance. So the focus distance as per the standard is this one. So this is your first focus distance. And if you have a tire, second tire, right? So if your second tire is starting from here, so you will have a second focus distance from the like for the second tier, for second floor stadium, right? So in stadiums, we have a terminology called tier 1. This is tier 1, that is ground floor. And we have tier 2 for second floor of your rows, right? And so on, right? So this is your focus distance, which is used, like, which is called F. And the number of rows. So you have given an option, like, if I have two tires, right, two floors, so how many rows will be in one floor and second floor? So you're just giving the, like, options. You're just providing an option over here. And over here we have certain values over here, that is A and E. What is A and E? Why we are using this kind of formula? So again, if I repeat those formulas, so this is just maths, right? So if I go to that slide, yeah. So if we are going for the focus distance, the total focus distance, so we need eye level, eye offset of the last, like, if as you know, the last row of the stadium is actually saved for barrier free, like for wheelchairs, right? For any, like, it is actually like if you are developing the barrier free stadium design, so the last row is actually kept fixed for wheelchairs, right? So that is why, like, the eye offset from that last row is the A, and the focus distance. So those things you need. That is why your D will be calculated. D as in the total horizontal distance from the point of focus. This will be calculated, right? So we have provided a quadratic equation. So the equation will be like this. So if we need to calculate D, and if we need to calculate R, so if D is equal to T minus A, like, right? So focus distance. So just providing these values over here in the C value, like C equation. So that is why we are getting a huge equation, like huge quadratic equation, or huge, we can say, mathematical equation. So this is actually pure math. So we are not calculating it. The Revit is, Dynamo is, generative design is calculating. We are just providing the information, the brief information that we need, that road, like row depth, riser height, focus distance. We are just providing everything. We are just using a formula. That's it. Everything is done by Dynamo. So let's check how this will work through generative design. So for that, what I'll do, I'll go to manage tab, generative design, create study. So generative design, again, it is a part of Dynamo, but with the AI, artificial intelligence, right? So let me go for create study, and I need to choose that script which I've made, stadium final. So I'll go for click on this, and over here you need to provide inputs, right? So I need several variations, like several permutation combinations for a few designs, right? So my main goal is the sight line The sight line should be uh, above 60, and like it can be above 150 or below 150. So again, it shouldn't be below 60, right? The sight line should be perfect, right? So the eye level, as you know, like A is for eye level, so this will be constant. First, focus depth, like this will be helping you to calculate C value, the sight line. So this is important. So the variations will start from here. And if I talk about tires, like if you have over here, so if you have two tires, so the corridor between that, so what will be the size of that corridor width, which will connect two tires? Either like maybe 1500, 2 meters, that is up to you. That is up to your concept, right? So let's, for the time being, let's make this as a constant. Number of rows, again, it's concept. So whatever number of like number of rows will be, it depends upon the sight line and all. So that is why I'm just going for the variations. Tread depth, right? Like the seat depth should be constant. That is again up to you. So if my every seat depth is 450, so I'll make it as constant. But if you want a design, if you want to make a design, you can do that, right? Let's go for generate. So what it will do, it will create several permutations and combinations, several concepts. And you can see over here, it is giving out the sight line. So 81 is okay, but like again, according to the descriptions, like according to the standards, 60 is minimum. So like if I talk about 90, that means you can still see the field, but you have to tilt your head. So again, like imagine like if you are watching a movie and you are tilting your head and you are not able to see anything, so that is kind of tricky. So this design is actually important. So if I talk about for this, let's take another, yeah. So first focus distance is 3700. So in tier 1, 26 rows will be there. In tier 2, 23 rows will be there, and the sight line value will be 107. So this is quite optimal as per your viewing standards. And if I talk again, like if I go with a different concept, right? So again, it is giving you various options to look into. And once you check, like once you are satisfied with the any with any design option, when like, so you can actually check, right? So let me take one example. So 193 is too much. So I need like below 50, or maybe like small maybe above 50, as in like 150, 160 and all, around 150, right? So yeah, that's, we can take 8 rows in first tier, 15 rows in second tier, right? So I'll go for this create. So now you can see the rows have been created. The rows have been created. After that, you can provide design. Like once the calculation is done, once the design is done, so from here, if you go to the manage tab, generative design, so over here you have that option. So it is again the built-in plugin. When when you install Revit, the generative design is actually there, right? Yeah. So okay. So once this is done, like once you have implemented a study, right? Once you have selected any kind of study and implemented in your project, after that the modeling comes. You are developing a BIM model. So for that, how to proceed, let's discuss. Yeah, let's take minimum. Yeah, that's enough. Let's take this one as an example, right? After that, like once the number of rows have been created, what you can do, just to remember what you have picked, like the information is very much important. So 3850, 12 rows, 2 rows in tier 2, and the inputs. These inputs are important so that you're developing the seats. Now once you have calculated the C value, the sight line, now these seats comes, the rows, right? The row thickness, right? So uh the row depth. Okay, so as per your stadiums, as per your flooring, as per your materials, right? You are developing profile for the stadium rows, right? So same, like same scripts you can use for profile family, right? So I'll open a new family, a new Revit. So for like from there we will be generating the row profile, right? So do remember those seating information that you have got from the, like from the generative design. These values are important for developing your seat profiles, right? So again, I'll use the same thing, generative design, like the Dynamo visual programming. So I'll, yeah, open it. Yeah. So for seats as well, I've created the script. So if you want to know about like more into dynamos and like, so you can contact to ARKANCE, right? So okay, so now if I want to calculate seats, right? So stadium seating. So I'm just creating a 2D profile for our stadium, right? So again, over here you need same thing, the road depth, the riser, right? So right, so I need to provide all these informations. So let's provide that. So first of all, if I'm talking about tier 1, so first distance will be 3850, the focus distance, right? And number of rows will be 12, right? So rest everything will be same, and the c value is important. So over here c value, you will be writing this 123.913. Rest it will be calculated automatically. So if I run the script, so you can see it is calculating again with the formula I've provided, right? Now as you can see, the profile has been created, right? We just need the first corridor width, like before your first row, as well as like once the floor is completed, the corridor width, which will connect the two tires, right? So this is important. And the distance over here, just observe, the distance is now perfect, right? The distance we have covered, and right, so everything that we have provided constant, everything, like it is on point. Now the next thing is, we just need to complete this profile and save it, and then we'll implement it in our main model, right? Right, so once this is done, I'll save it. Right, I'll save this, right? And in Revit, what I'll do, I'll link over here, like I'll go for model in place families. So these will be rows, right? And I'll just use pick path. So this is the boundary curve that we are taking the reference from where the row offset is actually happening. The first offset distance, the first distance is taking place. And I loading the profile. Yeah, I'll be loading the profile over here. So yeah, just give me a minute. So yeah, just give me a minute. Yeah, right. And I'll select the profile over here. So I'll provide certain elevation and then click on finish. Yes. So your according to your design, your rows are now created. You just need to provide the corridors and the steps, the gangways for the stadiums, like the spaces like where you don't have seats, right? So to climb up the stadium, like to climb up the stairs, right? So over here we'll have certain stairs, certain spaces like from where the players will enter, right? So after that you can provide the seating as well. So for seating you need over here the same thing, like the same script you will need to provide the seatings. So I'll just show you one example. So everything is going over here, like everything is going computational with, like from starting you have used generative as a design, like to check the concept, like to develop several concepts. Let me open that same script. So I'll just run it. So first of all, what I'll do, I'll select the seat which I need, right? So the same script we will be using. Again, the value should be same. So 3850, right? 3850. And the number of rows you need 12. Rest of the everything is, and the tier 2 will have row 2, right? And run, right? So just observe like how the seats are actually placed. Now for seats, you can just like this is just like normal auditorium seats. So for these, you can actually create specific seating, like stadium seats. You can develop it through family creation, and then you can rotate them. Like right now it is placed in, like in one, you can see it is working pretty fine, but again you have to rotate these seats according to the focus distance, right? According to the focal point, right? So this is how like you are using Dynamo, like the computational design, generative design, to develop your stadiums, right? So that is for today. So if now let's come to the Q&A session. So, so if guys, if you have any questions, uh, we can discuss.
Prakriti, I don't think so. We have any questions. So let's just wait for a moment and then we'll con.
Sure, sure.
Okay, yes, we have.
So I think there's a very nice comment. So yeah, you can actually add a tractor point. So a tractor point, what will it will do na? It will rotate your points, like rotate your seats as per your direction. So the tractor point will give you much more concepts, right? So as you can see like in cinema also, the like we have 4D arcades and several seats like where the seats actually revolve. So that also can be done through Dynamo, like the attractor point. So same scripts you can use everywhere. Right? I hope that answers your question. Yes, any more questions? We are free to uh, answer. Okay, so I think this
Yes.
is from me for today. So I'll be signing out. So thank you
Thank
all.
you,
You were
Prakriti.
the great audience. So thank you for coming. Thank you for joining. Okay, so bye everyone. Thank you.
Thank you.